Recording on Module 5, Composition of Functions. So before I go over the problems that I worked on for this video, I just want to bring up the fact that I haven't taught this before, and I honestly haven't even done these, and I kind of forgot they existed since I was in school. So this was an especially challenging module for me. So I'm doing my best here to try to pull this memory back up, and the lecture definitely did help a lot. It was a lot of information, but I kind of am doing my best here to, understand everything, and I can kind of relate to some of my students now who might, although they haven't, I've done this previously, but just trying to, catch on to something that is not something on the top of your mind. Anyway, the two questions that I chose to just put up here real quick were A and C. And real quick, just in order to really, for students to be able to grasp these kinds of concepts, this is where I'm seeing all these properties that we learned, the inverses, the identity properties, everything is so important. Reason being that terminology, just using the proper terminology. You can't just say, oh, you times this and you minus that, and just slang kind of math terminology in these cases as it gets more complicated and more advanced algebra. It's actually like super important now for students to know exactly what these operations are, how to say them so that we don't get mixed up in exactly what you're doing. So I am just going to quickly go over A and C and what I did. Because I haven't done this in a long time, so if I made a mistake, I'm gonna try to catch myself here, or if you see anything, let me know. So we have f of x equals 3x plus 2, g of x equals x squared plus minus 1. And I'm going to actually, for this example, I put it in the Desmos graphing calculator. So my school doesn't give calculators out to the students. Supposing that we have them somewhere. Everyone always kind of says someone else has them, someone else has them. So I never got calculators for my students. And we're getting to the point in Algebra 1 where we do need calculators. So Desmos can be something that'll be really, helpful to my students. So I put, just look at the top. Well, I'm going to take these two out for now. I put f of x, which is 3x minus 2, and g of x, which is x squared minus 1. I graphed them both in the graphing calculator here. So I have f of x is the red one, which is linear, and then I have g of x, the blue one. So what I did here was I just did f of g of x. I kind of like writing it like this. I just think it's easier to visualize. You see the g goes on the inside, and then g of f of x. So if f of g of x, I took the f of x function, and then I took that little g of x and made that equal the x and the f of x. So I just plugged all this in, the highlighted part right here, in for this little x. So this is what it came out to in the end. Same thing for g of f of x. I just took the g of x function and then took this whole thing, the 3x plus 2, and plugged it in for x. So that was a little bit of factoring that had to go into play there, but I just wrote out what the answer came out to. So there were definitely some different answers there for both of them. Seeing that we did the f of x and the g of x, and we were talking about the properties there. I believe we said it was commutative property does not apply. Correct me if I'm wrong. That's what we said was correct. So I'm going to really quick just graph this f of g of x and graph the g of f of x. I had those in here before. So f of g of x. Now it's putting it in a different color. It must be red again. So f of g of x is this one. It's just about to pop up. The this one here, the other red one. And I have g of f of x, which is the little skinny blue one here. So you can see there are different graphing representations. Then I did the inverse, finding the inverse for C. I've never done it like this. I've always, I think, done it, if I remember correctly, from so many years ago, plugged in the, switch out y and x, like you said, was commonly done, but I can see why that might be a little more, maybe more of a shortcut, but maybe not get the concept down. So I did the 3 steps that had to be done in this situation. So the power of 3, this was cubed here. The first the x was cubed. I'm sorry if I didn't write that right with the little caret 3. Then multiplied by 2, and then subtracted 7 or added -7. So I put them in the opposite order, inverse operations, where inverse operations come so much into play. And what I did was I basically do those operations back to it, and I got this. And if this is correct, I feel like I'm back in school, in high school, going through it again and again and making sure it's correct and hoping for the best on a test. But I did end up going through and testing out the v of z of x and the z of v of x, and I did get x. I'm not going to write that all out on here. It's going to take a long time. But I think this Desmos is going to be really helpful. The graphing. And other graphing calculator apps that were on there looked useful as well. This is definitely stretching my brain a little and making me recall some very old things from classes long ago. So that was my video for number 1 for Module 5.